have to evaluate the definite integral. Sin x plus cos x divided by 9 plus 16 sin 2x into dx from 0 to pi by 4. Let's begin with the solution. And let I is equal to integral of sin x plus cos x divided by 9 plus 16 sin 2x into dx from 0 to pi by 4. This can further be written as integral sin x plus cos x divided by 9 plus 16 sin 2x can be written as 2 sin x into cos x into dx, and the integral is from 0 to pi by 4. So this is further equal to integral sin x plus cos x divided by 9 plus 16. Now adding and subtracting 1, this can be written as 1 plus 2 sin x into cos x minus 1 into dx, and the integral is from 0 to pi by 4. This can further be written as integral of sin x plus cos x divided by 9 plus 16 into 1 minus sin x minus cos x square into dx. Since on simplifying, 1 minus sin x minus cos x whole square, we get 1 minus of sin square x plus cos square x minus 2 times of sin x into cos x, and this will give 1. Sin square x plus cos square x is 1, so we have 1 minus 1, and minus into minus is plus, so we get 2 sin x into cos x, and this is this term. Now let us suppose that t is equal to sin x minus cos x. So this implies, on differentiating both sides, dt is equal to cos x plus sin x into dx. Therefore, this integral can further be written as the numerator sin x plus cos x into dx is dt. So this can further be written as integral of dt divided by 9 plus 16 into 1 minus sin x minus cos x we have supposed as t. We have whole square, so t square. Now, when x is equal to 0, then t is equal to sin 0 minus cos 0. Sin 0 is 0 and cos 0 is 1, so we have t is equal to minus 1. So the lower limit is minus 1, and when x is equal to pi by 4, the upper limit, then t is equal to sin pi by 4 minus cos pi by 4, that is 1 upon root 2 minus 1 upon root 2, and this is equal to 0. Therefore the upper limit here is 0, and this can further be written as integral of dt divided by 9 plus 16, that is 25, minus 16t square from minus 1 to 0. This is further equal to integral of dt divided by 5 square minus 4t whole square from minus 1 to 0. Now we know that integral of dx upon a square minus x square is equal to 1 upon 2a log mod of a plus x divided by a minus x plus c, where c is the constant. Therefore, this integral, first let us write it in the form of a square minus x square. So let us suppose that u is equal to 4t. So this implies that du upon 4 is equal to dt. So this integral can be written as du, taking 1 upon 4 outside the integral, we have 5 square minus u square, and when t is equal to minus 1, then u is equal to 4 into minus 1, that is minus 4, and when t is equal to 0, then u is also equal to 0. So the lower limit is minus 4 and the upper limit is 0. And here a is 5. So using this formula, this integral can further be written as 1 upon 4 as it is. Then we have 1 upon 2a, that is 1 upon 2 into 5 log mod of a plus x divided by a minus x. So we have 5 plus u divided by 5 minus u plus the constant c from minus 4 to 0, and this is further equal to 1 upon 4 into 1 upon 10 log mod of 5 plus 0 divided by 5 minus 0 plus c minus of, now substituting the lower limit, we have 1 upon 10 log mod of 5 minus 4 divided by 5 minus of minus 4, that is plus 4, plus the constant, and this is equal to 1 upon 4, then 1 upon 10 log of 1 plus c minus 1 upon 10 log of mod 1 upon 9 minus c, and this is equal to 1 upon 4. Now log 1 is 0, so we have 1 upon 10 into 0 minus of 1 upon 10 log 9 raised to the power minus 1, and this is equal to 1 upon 4. This term is 0 minus of, taking this minus here, we have minus of minus 1 into 1 upon 10 log 9. So this is equal to 1 upon 4 into 1 upon 10 into log 9, that is 1 upon 40 log 9. Therefore, integral of sin x plus cos x divided by 9 plus 16 sin 2x into dx from 0 to pi by 4 is equal to 1 upon 40 log 9. This completes the solution.